Radio technology. Radio is the technology of signaling and communicating using radio waves. Radios pick up signals and turn them into sounds we can hear. They do this by using invisible waves that carry sound information. German physicist Heinrich Hertz discovered radio waves in 1888. He understood they were a form of energy, like light, that traveled in waves. But he did not see any potential practical uses. However, other scientists seized on his discovery, and within a decade, it was possible to send signals around the world without the need for wires. Thousands of different radio stations play music, news, and drama to listeners all over the world. Radio is based on the principle that electrical signals can travel without wire. So, it was also called wireless. Radio waves are electromagnetic waves of frequency between 30 Hz and 300 GHz. Italian Guglielmo Marconi was one of those who was inspired by Hertz's radio waves discovery. Starting in 1894, his experiments saw him transmit a radio signal a distance of 3.2 kilometers. In 1896, he received the world's first patent for a radio. Building on the work of British scientist John Fleming, American inventor Lee de Forest developed the Audion valve in 1906. This was able to amplify weak electrical signals and was crucial for the development of radio. In the US, de Forest is known as the father of radio. Development of radio. Early transmitters could send out radio waves only in short bursts and used Morse code. For proper sound, continuous waves are needed. In 1906, Reginald Fessenden invented an electric generator that could produce such waves. His first broadcast was on Christmas Eve, 1906. Regular broadcasting began in 1909. But it was not widely used until after World War I. In the early 1990s, English inventor Trevor Bayliss designed a radio for use in remote places where there was no electricity. It was powered by a clockwork motor that stored energy in a spring. Later radios, like this one, use energy from winding the handle to charge the battery. Digital radio. Digital broadcasting was first pioneered in the early 1980s. Developed at the Institut Rundfunktechnik in Germany. It was not popularly adopted until the early 2000s. But now broadcasters can offer more services and a higher quality signal than ever before. Although digital broadcasting was pioneered in the 1980s, the world's first digital radio tuner intended for home use did not go on sale until 1999. It was big and expensive. Smaller, more affordable units began to appear over the next few years, such as the pioneering Evoque 1 from British company Pure in 2002. The invention of radio was so revolutionary that developments since have made only minor improvements. Digital radio has massively increased the range of what we can listen to, but the experience of listening to the radio today remains little altered from a century ago. How radio works. Radio towers turn sounds into radio waves. Radios pick up these waves and turn them back into sounds that you can hear. Radio signals are carried by electromagnetic waves, which travel through space at the speed of light about 3 times 10 to the power of 8 meters per second. In a broadcasting studio, sound waves are converted by the transmitter into radio waves, which travel through the air from aerial to aerial, to be converted back to sound by the receiving set. At the broadcasting station, sound waves enter a microphone in which a metal ribbon, a coil or a crystal vibrates to change sound into electrical current. The electric current is fed through an audio frequency amplifier, which increases its strength, and this signal is combined with a carrier signal that is at higher radio frequency. The carrier is modulated by audio frequency signal. The modulated carrier signal is fed to transmitting area, where radio waves are emitted in all directions. The speed of the radio wave is approximately equal to the speed of light, and when reach the receiving areas, set up oscillating waves in it. The received weak waves are fed into a radio frequency amplifier to strengthen. Then they pass to a detector which separates the audio frequency signals from the carrier wave. The currents thus obtained are identical to those that left the microphone at the broadcasting station. They are amplified and fed to a loudspeaker. The loudspeaker acts like a microphone in reverse and provides sound like the original sound. Thanks for watching. If you like this video, please like, comments and subscribe to my channel and activate the bell icon to get new video updates.